Hello and welcome. Thank you for joining Red Hat and Insight for our discussion on edge computing. My name is Jacob Thomas, Red Hat Business Development Manager here at Insight, and I am joined by Red Hat Associate Principal Solutions Architect Sam Richmond and Insight's Senior Field Architect Frank Perkowski. Frank is a former CTO and technical VP. With 30 years of experience, Frank can help turn traditional operations into a center of excellence. Sam has become a subject matter expert on edge computing and supporting the DoD, and is a member of Red Hat's global Zero Trust community practice. Today we'll be discussing the benefits, challenges, and unique use cases for edge computing, and how Red Hat is paving the way for public sector clients, and Insight's perspective on where we see edge computing workloads being utilized today. Insight has a long history in selling IT products and solutions. First formed in 1988, Insight has grown from a traditional technology reseller to a solutions integrator, where we have the ability to customize solutions to client needs. Insight has many capabilities in data and AI, cybersecurity, intelligent edge, device as a service, and the list goes on. We've been able to evolve Insight into a solutions integrator due to key acquisitions that have given us great advantages and expertise across many areas of technology and data. But why Insight for Red Hat? Insight has been a top 3 partner from 10 years in running, and we are key partners with many other infrastructure technologies that integrate with Red Hat, like Portworx, Cisco, Palo Alto, NetApp, along with many others. Insight also has a robust group of engineers supporting our sales team to help understand all of your client challenges and needs. When it comes to solutions at Insight, I'm going to hand it off to Frank Perkowski, Senior Field Architect at Insight.
Insight's Red Hat expertise is nearly unparalleled. Whether you really are just beginning or you've got an embedded base of enterprise Linux, middleware like JBoss, Ansible, regardless of your position in your journey, Insight can help you operationalize and integrate Red Hat products and services to help you succeed. One of the biggest benefits we bring is that we understand Red Hat while also understanding how it fits into your infrastructure, into your architecture, and into your operations plans for your businesses. So bringing it to automation, bringing it to cloud, bringing it to your data center, all with the same familiar sets of tools, the same familiar look, and the giant advantage that open source brings to your organization. Sam, do you want to take a minute and start talking a little bit more about what Red Hat does here?
No, absolutely. I mean, I think you hit it on the head, right? The concept of open source certainly being a fountain of innovation for the world, and being able to offer those open source capabilities with the enterprise supportability that Red Hat provides is critical. It also aligns really well to the edge conversation that we're going to have around, to your point, consistency of management, consistency of platform, as well as the interoperability advantages that open source does, because of course every enterprise and edge deployments are multi-vendor, multi-technology, and so our proficiency in open source and open protocols really enables our customers to build these maintainable and scalable architectures.
Yeah, and I think you hit the nail on the head there, sir, because the reality is we will never get to the point where we can effectively utilize edge computing until we make it repeatable, until it becomes muscle memory to the organization. So utilizing tools like Ansible to make sure that workloads are consistent, make sure they're compliant before getting promoted into production, making sure that we can upgrade, let's say, Red Hat enterprise instances using satellite instead of tools like Yum or other non-enterprise types of upgrades within the enterprise, can assure that we will remain secure, consistent, flexible, and agile. Why don't we take a closer look? Oh, go ahead. I'm sorry.
Oh, I couldn't agree more.
Let's take a closer look. Let's go to the next slide.
Yeah. So I think with that, keep those things in mind that Frank mentioned. When we think about edge computing, it really changes the paradigm of what we're trying to build. A lot of us started out in the enterprise, started out in the data center, and we knew how to build things there. And when we think about cloud, a lot of those concepts generally translate to cloud computing. Edge is different. What is edge? Let's talk a little bit about that. So certainly the images on this slide should give you some clues as to what edge means. Now, all of these different domains share a lot of things in common, but one of the big things that they share is that they're distributed and not centralized. So whether we're talking about defense use cases or critical infrastructure or healthcare, disaster response, power, smart vehicles, all of these things are out there. They are not in the data center. They are not in the cloud. And generally speaking, they're extremely dynamic and time sensitive. So where did the concept of edge start? A lot of us consider the telco use case is kind of where the concept of edge started out. Because if we think about what does telco mean, especially now with 5G devices and high throughput, video streaming and telemetry and millions of devices, these are out there too, right? These aren't in a data center. These are out there. They're closer to a cell tower than they are to whatever the telco central core is. And so a lot of the edge architectures are aligning to how telco created these to support their use cases. And it aligns really, really well to all of these other distributed time sensitive use cases. So keep that in mind as we have this conversation about what edge is, because in all of those use cases, most data that is used is generated outside of that data center or cloud architecture. So edge computing literally means putting compute and storage closer to where data is generated. Now, what does closer mean depends on the use case, but ultimately you're putting that compute and storage closer to where the data is used and where it needs to be where it's generated and needs to be used in a very time sensitive, manner. Whether it's a cell phone, whether it's a smartphone, whether it's warfighters out deployed downrange, these things have to happen very quickly, and they all need to be very localized. And so, think about that in the context of your use cases and where edge can fit in. So to kind of talk about more of those subtleties and nuances of edge and what kind of problems they're solving, Frank, can you talk about that for a little bit?
That's a terrific description. I like to think about the edge for our clients as that part of our area of responsibility or area of concern that impacts the rest of the world, right? Truly, the edge is everywhere. So thinking about where the edge of my concern is as an enterprise or as a public entity, that defines edge computing, I think, more than anything else, because we need to gather, to your point, telemetry from the edge, and we also need to process it safely and securely at the edge so that we can start making decisions quickly. Almost thinking around that fail fast mentality that developers utilize. We will fail sometimes in the field. All of us will. That's the nature of humanity. But if we can utilize quick, effective decision making by having that telemetry, having it processed, trending it against our known outcomes, then we can be more efficient. By becoming more efficient and by becoming more agile and quick, we can actually improve the outcomes for the citizens. Let's say, for example, where a town who's managing a large media event, maybe a concert, right? Having that effective decision making at the edge can allow us to redirect traffic, improving our citizens' experience as they come and go. And it gives us the ability to manage from pretty much anywhere. We can have 2 or 3. We can have a primary field command center, secondary, tertiary, all of them sharing data, sharing telemetry, and even more importantly, sharing analyzed results and making that decision quickly, all with the included security that we'll talk about a little bit more. I know you will, Sam, making sure that our data is secure and that we're compliant with regulations regardless of where we are. Do you want to talk about that a little bit more?
I do. Before we kind of do that, I want to double down on what you said, right? Thinking about redundancy and responding to events, whether they're organized or whether we're talking about some kind of localized mass casualty or some other disaster. Redundancy and speed of and agility of response is highly critical. I spent over a decade as a firefighter in Maryland here, and I know firsthand just how quickly situations change and how effectively one has to respond to things. And so when you're building your edge architectures, again, one of the characteristics of it is dynamism, scale, and speed. And so, as you think about the technologies that we're going to talk about today and the use cases, keep that in mind, that the things you're building need to align to the use cases and the criticality of what your use case is. Again, whether it's, response to an event, like you said, or wildland firefighting, or infrastructure, all of which are unfortunately targets of adversarial attack. And so, not only responding to things quickly, but also thinking about the adversary and how they're going to potentially attack or disrupt it is highly critical. And that's even more important in edge. But before I pontificate on that a little bit more, Frank, I'll let you talk a little bit about more of the problems that these all have in common.
Hey, thanks, Sam. Listen, I think you hit the nail on the head there again. Okay, so I guess we agree on a lot of this stuff. The reality is that whether it is a forest fire or structure fire, whether it's a concert, whether it's a flood, whether it's some other type of disruption, whether we're with the Department of Defense, whether we're with the utility companies, regardless of where we are, most of these distributed problems have a lot in common, right? And it really comes down to, how do we handle the edge? How do we respond at the edge? And how do we build our solutions to be mission critical at the edge? So, kind of digging into that a little bit more, right? So I think a lot of us are very familiar with the DoD use cases. And what we probably don't realize is that we do the same things in public sector. So we can fly drones overhead, I know you've got a lot of experience here, but in the scenario of, a structure fire or a forest fire, we can fly drones overhead. We can actually fly overhead, cellular repeaters, so that we can have connectivity for our voice and data traffic. We can tie that into, portable command centers that have 10-foot, 15-foot screens, and connect in all of the information that anyone might need right at their fingertips. And we can have 2 or 3 of those distributed, so that if one needs to move, a redundant location can pick up the slack. And because edge computing is so agile, we won't lose a beat in trying to respond to that citizen situation or emergency. Or even if we looked at, a commercial or enterprise use case, the same types of distributed architecture and distributed information problems occur everywhere. Why don't we move forward a little bit, and we'll take a deeper dive into some of the technical characteristics that Red Hat brings to bear here, Sam?
Yeah, definitely. And I think, we'll double down a little bit on some of those challenges that you just talked about. Because again, as I think we both alluded to and stated clearly, edge is different than enterprise. And there are a lot of reasons for that. I mean, the first, physics is physics. You can't make light go fast.
Right?
Right. You can't make light go faster. You can't make the EM spectrum go faster. It is how fast it is. So the further you are, the higher latency you're going to have. That's just a fact. So if you're having to making quick decisions in the field, you don't have time to solve that problem in the cloud or in the data center, because by the time it gets there and back, the problem has changed. So physics is physics. You can't change that. So move your stuff closer to the problem you're trying to solve with edge. The bandwidth challenge is real, right? We're getting a lot better at moving a lot of data over 5G, but especially when we're talking about disaster or DoD use cases, those kinds of high bandwidth wireless connectivity are not guaranteed. And especially when you're dealing with a lot of sensors. If you deploy a swarm of 1,000 drones over a wildland firefighting area and you don't have cell towers, now you're dealing with lower bandwidth EM, or maybe SATCOM that's lower bandwidth. And as you add all those up, you start losing the ability to move a lot of data over them. So solving the problem locally, and to your point, processing it locally is critical. Please go ahead, Frank.
Yeah, and I was just going to add to that. So especially in public sector, right? One of the areas where it might be a little bit different than DoD is that communication in public sector, because what tends to happen on the battlefield is that we can dominate the communications from the air. In the United States, in a public sector environment, when a municipality is out there, every cell phone is calling somebody. Everyone's taking video and posting it to social media. So the bandwidth constraint becomes even bigger, which means we have to be even smarter at the edge, right? Physics is physics. There's only so many carriers available in the frequency. and there's so much interference that we need to overcome. Go ahead. I just wanted to add that little bit.
No, it's 100% spot on. I completely agree there. And I think that kind of again dovetails into the security aspect of this, right? We assume certain levels of physical control in a data center or in a cloud, right? There, it's localized. You know where it is. It's there. You have controls over those devices and the data that resides on them and transmits and gets ingested by them. But on the edge, you have devices out there. They are out there. Your assumptions of physical security are oftentimes moot, and the data that they generate, process, and transmit is at risk. And so, building technology into those edge devices to secure, and I'll use some data security terminology here, data at rest, so stored on the devices, data in motion, moving off the devices or into the devices, and data in use, data being processed on the devices needs to be secured. And so when we talk about the Red Hat portfolio, there are capabilities across the portfolio that allow encryption for all of those three kinds of data handling use cases. So think about that from an edge use case. Security is very different on the edge than it is in the cloud or data center. I think you touched on availability and disruption of services, Frank, and that can be for a lot of reasons, right? That can either be intentional. The DoD, that's something we think about a lot. Even in civilian and local use cases, intentional disruption can be a thing. And so building,
absolutely,
right? So whether it's disruption from a weather event, right? Now all of a sudden you don't have comms to your data center anymore. Those things have to operate locally because they have to, or if they're purposely disrupted. So making that availability of critical functionality at that edge device makes incredible sense and is highly critical. And then the last two things here are really kind of important as well. So resource footprint, right? As you get smaller from an edge device, you lose resources, right? So you have low size, weight, and power. You may have seen the acronym SWAP out there. So what you can put where is very dependent on what you have available. And so either, size it appropriately for the edge device you have, or think about an aggregate, right? If one edge device is really, really not terribly powerful, what if you could mesh together 1,000 of them? Right? What kind of capabilities can you achieve that way? And so always think about aggregates, what you have on individual things as to what workloads need to go where and how they need to communicate with each other. Really, really important to think about when you're building your edge use cases. And finally, I think that also talks to scale, right? We're talking about hundreds or even thousands or tens of thousands of devices. Managing them, maintaining consistency across them is incredibly critical. How do you build them out before they get deployed in the field? How do you update them while they're in the field? How do you deal with attrition? That is a terminology we use often in the DoD, right? How many of that group can you lose without losing functionality? So refreshing them, updating them, and so on is really, really important. And those are kind of emergent challenges with scale. So Frank, I think you had a point to bring in.
I think that's a great point. And that goes all the way back to how do we maintain a standardization that we will require? How do we maintain a library of these types of resources that are up to date, compliant, secure, and ready to deploy, right? And that's really where all of this comes together, kind of like we talked about before, is great technology designed and deployed well to solve the problem.
100%. And I think, Red Hat is incredibly well positioned to do that. And I'll talk to our portfolio in a moment. The last thing I'll bring here is when you hear edge, there are many edges. And how many edges you use is dependent on your use case. But think about, again, where your problem sits, where you need to make decisions, and how much infrastructure you may already have implemented, and what needs to be kind of in the field and is much, much smaller. Not every use case has every edge. We steal this from our telco friends a lot because they're very, very similar, right? As you get closer to the enterprise, your footprint gets bigger, your capabilities get larger, more permanent, and as you get further out to the left here, it becomes more ephemeral. And so when you're thinking about your edge use cases, think about where you need to make tactical decisions and where you need to make strategic decisions. Tactical is generally to the left and strategic is generally to the right. So as these things feed data in to the central core when possible, that's where the strategic decisions come in. That's where machine learning models get trained. That's where applications get built and iterated, and then those smaller things get pushed to the edge for execution. And that kind of flow may sound a lot like DevOps or DevSecOps to some of you. And if that's the case, then you're absolutely right, because that's what you're doing. You're constantly iterating, and you have a constant infinite loop of testing, monitoring, and deployment and redeployment that goes on from the edge to the enterprise. So really important to think about.
Hey, Sam, a great point there. And I, like I said earlier, almost that fail fast mentality. But what I love about this particular slide is, and I'm a little bit older, right? So I'll go back to my electrical engineering degree and training and say, what's terrific about edge computing with, Insight and Red Hat is building in that, what we used to call a feedback loop, which is literally a circuit that just measures resistivity or whatever it might be, to give intelligence, actionable intelligence back to the system, right? So what I love about this is that you build feedback loops between the small edge and the large edge, between the small edge and the enterprise, between the mobile field operations and the large edge, right? Building feedback loops into this, sharing the telemetry, sharing the analysis quickly, right? Which is going to lead to much more actionable, much more agile intelligence and decision making.
Oh, 100%. And it's, again, to get to the point of, back to where we these are consistent shared problems. I mean, the DoD, the concept of the OODA loop is still valid, right? Or observe, orient, decide, act, and then go back to the beginning and do it all over again, right? What did you learn? How can you improve your next action? So these are all shared problems. And I think that, it's really important to remember that, and we can all learn from each other.
Yeah, 100%.
Oh, yeah. So let's talk a little bit about technology, right? We're talking about concepts and building architectures. When it comes to what technologies Red Hat can provide to solve these problems, there's quite a bit. So the Red Hat vision has always been the concept of multi-hybrid cloud. So where does the problem need to get solved? Can it be solved with one cloud, multiple clouds, or a combination of cloud and on-prem? And if you really boil it down, Edge is technically on-prem. It's just a lot of little on-prems, right? Or a tiered level of on-prems, right? It kind of is, right? Your drone is a data center. I mean, it's a small one, but it's a data center. And right. So the portfolio, yeah, exactly, right? And so the portfolio that we provided really aligned well to that. So we sell to telco, we sell to everybody, because the concept is really at its core the same. And so that consistency applies across our portfolio. So we have some very specific solutions, like, for example, the Red Hat in-vehicle operating system, or RIVOS. It's specifically designed for connected vehicles. We have partnerships in the industry. It has some safety critical capabilities that other instances of RHEL don't need. But ultimately, it's RHEL, Red Hat Enterprise Linux, at its core, as is our Red Hat Device Edge product, which is, again, based on RHEL, but incorporates some edge specific capabilities like Delta updates over the air updates. So you don't push an entire operating system update if you need to update it. So right. Again, leading to the physics is physics, low bandwidth, low bandwidth. Lightweight Kubernetes instances for container management orchestration, and Ansible, of course, for automated configuration management and also orchestration across these many edge devices. So, but again, based on RHEL. So again, consistency around security controls, around management, going all the way through the portfolio here. And then finally, kind of to the point where you have a bit larger footprint and you can deploy something like Red Hat OpenShift Container Platform, a more enterprise container management and virtual machine management platform where it makes sense, as well as Red Hat Enterprise Linux, kind of your standard deployment for a data center or a larger form factor edge server. It's all the same, right? Everything is based on RHEL. Even OpenShift runs on Red Hat Core OS, which is based on RHEL. And so, yeah, exactly. And so that consistency, again, lets you do these useful abstractions like AI ops, ML ops, developing containerized applications at the core, moving them to the edge, and then all the way out to the far edge, right? And then security controls across all of them. It's baked into every layer. Like we co-developed SE Linux with NSA back in the day. Red Hat Enterprise Linux incorporates SE Linux. OpenShift uses SE Linux. And then stitching it all together with application and data services to, again, build those connectivity fabrics, both in the field, at the edge, and between the edge and the core. So our portfolio really does span that entire breadth of of far edge all the way into core and enterprise and cloud.
And Sam,
Yeah,
before
please.
you go on, what I love about what you just stated, and from the perspective of our clients, it's a challenge. When I think about that three-legged stool of IT, right? The people, the processes, and the technology, right? This is a challenge we all face. I was an operations manager and director and VP for many years before I moved to the integrator side of the house. Bringing in new tools, retraining people, and all of those types of initiatives, they cost time and they cost money. And oftentimes we need to recruit new talent. It's a huge advantage. And you said it already. This is the same set of tools. It has the same look. It has the same feel. It doesn't matter if it's in the data center, on the edge, in the cloud. It doesn't matter where it is. It will always be the same look and feel. And because it's open source, I love all of our software manufacturers. Every software manufacturer has a limited budget, a limited talent pool. Open source changes the model because there are literally millions and millions of developers out there trying to fix it, and there's millions and millions of developers out there trying to break it. So having a secure, resilient platform with the same look and feel from the core to any of the hundreds of edges or thousands of edges out there and cloud, that's an unbeatable combination when it's deployed properly.
Oh, I couldn't agree more. I mean, the open source model is so critical for the operational aspects, from security challenges. We've seen some potentially catastrophic industry bugs get solved very, very quickly because the software is open source, right? With more eyes on it, the faster we can come to a solution, the better people can interoperate and collaborate. And so, to that point, just to kind of double down on it, right? From a platform perspective, consistency from the core to the edge, whether it's Kubernetes, whether it's data services, whether it's the operating system itself, is critical. Automation from edge to core, incredibly important, even with intermittent connectivity, which is honestly an assumption of edge, right? Don't just say if, it will. That is the point. Edge is designed to handle intermittent connectivity and isolated operation from the core. It has to. Security, again, to your point, if it's open source, we can collaborate. People can collaborate. Red Hat publishes SBOMs or software bill of materials, so you can see what's in the code, and then you can see this SBOM and actually look at the code itself if you choose to. Don't take our word for it, right? We provide security around our portfolio, immense amounts of security rigor, but we also publish SBOMs, and the security and the code is out there. So, if you think zero trust, you want to trust the vendor, but don't trust the vendor, right? Trust but verify, right? Always check. And that's another strength of Red Hat in our open source model, is that you can do that. From a safety perspective, again, we have safety critical certifications around some of our products like Red Hat in-vehicle operating system. That's something that we develop with industry. And so you get to take advantage of those industry partnerships as well when you kind of go with the Red Hat portfolio. And it's the heterogeneity of the thing. We are building to the edge. The edge is a lot of different things. It is ARM, it is x86, it is small form factor. There are a million edge device vendors out there. And so by kind of leveraging our innovation and our ways of building stuff from an open source perspective, we can better address the concept of kind of hardware and technology heterogeneity because of that and our partnership in the ecosystem. So really important to consider, especially with edge, because it is so varied and heterogeneous. So I think to wrap it up, just to kind of if we think back to the diagram earlier about how many edges there are and what it looks like, and kind of overlaying the big blocks of the Red Hat portfolio, I think it becomes a little even clearer to where we play, right? You build your architecture based on what capabilities and components and workloads need to live where, and having that consistency of Red Hat OpenShift, Red Hat Enterprise Linux, Ansible, app foundations to stitch things together is really critical to building that, again, Frank, to your point, fail fast, continuous feedback loop from core to edge. So I think, our portfolio aligns really, really well to that challenge.
Yeah, I agree. And, just to go a little bit deeper, right? Because we can optimize that same set of tools, because there are specialized I'll call them distributions. I realize it's really not the correct word because they are slightly different products, but because they have been optimized for various roles within the data center at large, whether that's edge, co-location, cloud, core data center, because I can do all of this together, and because I can do this in an open source model, that gives me maximum flexibility. Again, going back to my IT operations management days, right? That gives me maximum flexibility because now I can choose ecosystem partners that will help me achieve my goals, as opposed to, and I realize often these are golden handcuffs or, comfortable handcuffs, but as opposed to being locked into a specific private ecosystem that may not give me that flexibility and agility that I really need, especially out there at the edge. But because I've made specific decisions at my core, I'm locked in. I don't have the abilities that I would have had originally. So I love this approach. I think it's a winning approach for our clients. I think it's a winning approach for public sector because it allows public sector to respond, whether it's a positive event, a negative event, or just another day, at City Hall. It gives us the ability to respond as quickly as possible to the changing public condition.
Yeah, couldn't agree more. And I think, yeah, well put. And ultimately, remember, the mission informs the architecture, not the other way around. So having that flexibility and having that consistency allows it to work that way versus trying to stuff a kind of a fixed, static, and rigid architecture into missions that are incredibly dynamic, like Edge, that are well suited for Edge. So excellent point.
So, Jacob, what do you think? In summation, uh, in my opinion, I think that this is a winning combination for our clients. And I think that Insight is definitely dedicated to, building the relationship further with Red Hat and with our public sector clients. I think this is a winning combination.
Yeah, I couldn't agree more, Frank. I think that the capabilities between Red Hat and Insight pair together quite well, and it's definitely a winning formula.